Okay, today we're going to look at section 6 in our triangle congruence unit, and this one is called CPCTC. So let me first begin by defining what that stands for. So I'm going to write the acronym vertically, CPCTC. So this stands for corresponding parts of, so the word of is kind of over to the side here, corresponding parts of congruent triangles are, so R doesn't really fit in the acronym, so ARE. So we have corresponding parts of congruent triangles are congruent. Oops, I wrote my C out there twice. Let me zoom in here a little bit. All right, so corresponding parts of congruent triangles are congruent. And so this acronym it's actually, I guess a property you could say. But it basically says if we know we have congruent triangles, so if we ended with SAS or AAS, if we have congruent triangles, then all the other corresponding parts are also equal. So we are not going to end our proofs today with triangle ABC congruent to DEF, for example. We're going to end with how do you know side AB is equal to DF? So let's jump in here and look at an example. Example 1 says A and B are on the edges of a ravine. A ravine is sort of like a, I guess you could call it a big valley, but something that's really deep with real tall sides. What is the length of AB? So we're trying to figure out the length of AB. So I can use congruent triangles to get there. So let's mark what we know to be congruent on the picture. So I see a 15 here and a 15 here. So I can mark these two sides congruent. I see a 10 and a 10. So I can mark those two sides are congruent. So I should put double marks. And then I have vertical angles right here. Okay. So everything I have marked on here allows me to say the two triangles are congruent by SAS. So if that's true, then all the other pieces are also congruent. Like for example, this angle that I'm going to put a dot on is the same measure as this angle down in the corner and the other two angles. And for that matter, the two sides. So I know that the side I want corresponds to the side I need. So I know they're both 18. So I can say that AB is 18 because once I know all the triangles are, if the two triangles are congruent, all their corresponding other parts are also congruent. Okay, and so the reason I know it's 18 is because of this CPCTC. And again, that stands for corresponding parts of congruent triangles are congruent. Okay, so let's try this in a proof. So it looks very similar. We have a given and we have a proof. But notice we're trying to prove two angles are congruent, not two triangles. But everything is pretty much going to be the same until the last step. So I'm going to start with statements and reasons. Okay, and so line 1 is going to be my givens. YW bisects XZ. And then XY is congruent to YZ, and that is given. So I'm going to mark the two segments, XY, YZ. Now, what I would do probably is I would read the first given and think about what happens after that. YW, this middle segment, is chopping. You know what? I noticed I have a problem on here. This should be a Z. Sorry about that. Change that to a Z. I have a typo on there. Scoot that over. I don't think that's on the screen. Okay, so I need you to change that to a Z. Now let's look at our given. YW is bisecting XZ. So XZ is being chopped in half. So I can mark XW equal to WZ. So I'm going to write that as line 2. Segment XW is congruent to segment ZW, and my reason is definition of bisector. Definition of bisector. Okay? I also look back at my picture. I'm still trying to show the triangles are congruent. That's still my goal. So I have reflexive here. Let's mark it. And so now I can say that YW is congruent to YW. YW congruent to YW. And that is my reflexive. Reflexive. Okay, so I have SSS. So let's show the triangles are congruent. So step 4, I don't have the names up here, so I need to name them in the right order. So I'm going to start with X and go X, Y, W. So triangle XYW is congruent to, so Z goes with X, so I'm going to have to go ZYW. Triangle ZYW. And that is SSS. So I want to show that these two, so let's find XYW, this dot right there, is congruent to ZYW, this dot. Okay, and so since I have shown that these two triangles are congruent, W and W are in the same position in the name. And so remember, if two triangles are congruent, all their corresponding parts are congruent. So I can use that reason to finish out by saying that these two angles are congruent. So angle XYW is congruent to angle ZYW. And I'm going to use this new acronym at the top here. I'm going to use CPCTC because all those corresponding parts are congruent. So that would be CPCTC. Okay, so we're really just continuing proofs and adding one more line there. Okay, so let's do the second one. If you want to try this on your own, you can. Go ahead and pause the video and get as far as you can and restart it. Statements and reasons. So number 1, I'm going to write my givens. So PR bisects angle QPS and angle QRS, and that is given. So number 1, given. Now, I can't specifically mark anything right now, but I'm going to use that to find equal items. So I have PR here in the middle. Actually, before I go any further, I'm trying to show, let's look what we're trying to prove. We're trying to prove that PQ is congruent to PS. So I'm going to have to end with CPCTC, but before I do that, I have to show triangles congruent. So if PR is bisecting both angles, find these angles, QPS, this angle right here, and QRS, this angle. So this is bisecting both ends. So I can come around here and say that these two angles are congruent, and then the angles that are congruent. So that's going to give me a couple of lines, and the reason is that the bisector, it's just definition of bisector. So I'm going to name these first angles. I'm going to call this QPR and SPR. So angle QPR is congruent to angle SPR. And then let me write my other one because it's going to be the same reason. QRP, so angle QRP congruent to angle SRP. And my reason is definition of bisector. Okay, so I have two angles. I need another item here. I have reflexive. Mark your reflexive. So I can say PR congruent to PR. So segment PR congruent to segment PR. That's my reflexive property. Reflexive property. Okay, and I have one of my 5 reasons. I have ASA. So number 4, I'm going to name the triangle. So I'm just going to start with Q. I'm going to say QPR. So triangle QPR is congruent to triangle. So if I started with Q, I have to start with S. So S, and then the 2 angle P's are congruent, SPR. So you have to make sure when you name your triangle, you name it accurately with what parts are equal. Oops. ASA. Okay. And then I'm ready to show that the last 2 sides are congruent. So now that this is true, I can look in my triangle name, and here is PQ, and here is PS. So those are my corresponding parts. So I can rewrite what I'm trying to prove. PQ is congruent to PS, and that is our corresponding parts of congruent triangles are congruent. CPCTC. Okay? All right, let's see what we have on the next page. Let's just do a couple more. Let's see. Okay, let's do number 3. Again, you might pause the video and challenge yourself to try to get it the solution on your own. You're going to show the triangles are congruent, and then we're going to show that these lines are parallel. So we have statements, reasons. My first given here is going to be segment NO parallel to MP and angle N congruent to angle P, given. All right, I'm going to mark my parallel segments. NO gets a parallel mark, MP gets a parallel mark, angle N gets an arc, and so does angle P. Okay, so my goal is to show triangles are congruent. So number 2. I see reflexive right here. Let's mark reflexive. So I could say MO congruent to segment MO, reflexive property of congruence. Okay, and if I have a set of parallel lines, I have some angles. So I'm going to extend out my parallel lines. Here's my transversal. So I know that angle O up here in the upper right-hand corner is congruent to angle M in the lower left by alternate interior. So I have angle NOM congruent to angle PMO, and that would be alternate interior angles theorem. So I have congruent triangles right here. I have angle, angle, side, AAS. So number 4, I can say NOM, triangle, NOM is congruent to PMO, triangle PMO. And notice my lines 3 and 4 look almost identical, which is fine. One's an angle, one's a triangle. So I have angle, angle, side. Okay, now to show I have parallel lines, I'm going to have to use a converse of something. So if I can, let me see here, let me grab another color. If I can show I have another set of angles, then that are congruent, I might be able to use a converse. So I'm going to do this. I'm going to turn my picture like this. And so because my triangles are congruent, all the other pieces are equal to each other. And what I mean by that is if I put a dot right here and a dot right here, I know that those two angles are congruent by our new CPCTC. And if those two angles are congruent and they're alternate interior angles, I can say the converse tells me my other two lines are parallel. So I am going to, in my next line, I am going to name these two angles and call them congruent. So this might be angle NMO. Switch back. Angle NMO is congruent to angle POM. And I know that it's congruent because of my corresponding parts are all now congruent. So CPCTC. And so if you recall, your converse says if you can show that you've got congruent corresponding alternate interior angles, then the converse of that says your lines are parallel. So I can say that MN, segment MN is parallel to OP, and my reason is the converse, so I'm going to abbreviate converse, of alternate interior angles theorem. Okay, so this one's a little bit more tricky in that you have to use CPCTC to get to your converse. Okay, let's wrap this up. One more example here. We are going to be given a bunch of ordered pairs. We're trying to prove DEF is congruent to GHI. So what I want you to do is I'm going to separate down here. These first three are a triangle, and then these next three are a triangle. So let's plot those. So -5 would be right here. And then -3, -1 is right here. And then -2, -3. Okay, so this is D, E, and that was F. And then the second triangle would be -2, +1, 0, 1, 2, 3, 4, 5, and then 1, 1, 2, 3. So that's I, this was H, and that's G. Okay, so the question or the problem says to prove that these two angles are congruent. So we're going to plot them. We're going to use the distance formula to find the sides. So I want to find the side length of ED, DF, and EF. So I'm going to work with this triangle down here. So I'm going to write down what I'm going to do. Now, if you want to use Pythagorean theorem, you're welcome to try that out. So I need the length of DE. I need the length of EF. And I need the length of DF. Now, DE are the ordered pair -5, -5, and then E is -3, -1. So I need to plug into distance formula. So distance formula, remember, is to subtract the two x's and then square it, and then subtract the two y's and square it and add those together. So I'm going to do -3 minus -5. Squared it, plus do your y minus y, -1 minus -5, and square it. Looks like I'm going to need a little more room here. So that's going to give me -3 minus -5. I can do, these two become positive. So this in parentheses gives me 2, 2 squared is 4, plus, make those positive. That's going to be 4, 4 squared is 16. So that is going to be the square root of 20, which I'm going to leave it as square root of 20. So that's square root of 20. Okay, so let's go through DF. Okay, so DF are going to be this first ordered pair and the last. So I'm going to do x minus x. So -2 minus -5 squared. Y minus y, -3 minus -5. -3 minus -5 squared. So let's simplify. So I'm, again, change the two negatives, they become positive. So that's going to be a 3. 3 squared is 9. You change opposite again here. So 5 minus 3 is 2. 2 squared is 4. So 9 plus 4 is 13. So the square root of 13. So that is this one. Okay. And then let's do the other two, EF. All right, so here is E and F are next to each other. So I'm going to do -2 minus -3. -2 minus -3 squared plus -3 minus -1 squared. So I get, leave change opposite again. So I'm really doing -2 plus 3 is 1. 1 squared is 1. Leave change opposite. So that's going to be a -2 squared is 4. So I get square root of 5. Okay, so I need to see what I get on the other triangles. Okay, so I want to do GH, GI, and HI. So GH, I get G and H. So I'm going to do 0 minus -2. 0 minus -2 squared plus 5 minus 1. So I get, let's see, leave change opposite. That would be a 2. That would be 4. 5 take away 1 is 4. That would be a 16. 16 and 4 would be 20. So I get square root of 20 here. So these two sides are congruent. My next one I'm going to look at, let me zoom out here a little bit. I'm going to look at GI. Okay, so I would do first and last. So 1 minus negative 2 squared. The 3 minus 1 squared. So 1 minus negative 2, leave change opposite. That's going to be a 3. 3 squared is 9. 3 take away 1 is 2. 2 squared is 4. That's 13, so that matches the other one. And I probably should get negative or square root of 5 here, so let's check that real quick. HI is going to be 1 minus 0 squared, and then 3 minus 5. 3 minus 5 squared, so I get 1 squared is 1. That's going to be a negative 2, square root is 4, square root of 5. All right, so I have just proven that these two triangles are congruent by SSS. So the question is, how do I know that angle DEF, this angle right here, how can I prove that DEF right there is congruent to this angle? And if my triangles are congruent, then I know that angle DEF is congruent to angle GHI by the CPCTC. Corresponding parts of congruent triangles are congruent. So I have got to show triangles are congruent first, and then I can apply this. Okay, and that wraps up this section.